Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you'll learn about AWS services. Many of my audience were talking about making a video about Amazon Redshift Serverless. So here we go. Today I'm going to talk about some of the key features of Amazon Redshift Serverless. Now we all know that Amazon Redshift is a data warehouse service from AWS which can be used to set up data warehouse for the organization. So if you talk about Amazon Redshift Serverless, it is the serverless version of Redshift. That means you can create a data warehouse, but you don't need to manage any infrastructure. So you don't need to manage any compute infrastructure, storage infrastructure, but you can run a data warehouse using Amazon Redshift Serverless in AWS. So that's a short introduction about Redshift Serverless. So let's try to understand if I'm trying to provision Amazon Redshift Serverless, what exactly it means. Basically, provisioning Amazon Redshift Serverless for data warehouse, you need to configure two components. One is called namespace, and other component is called workgroup. In namespace, basically you use it to create databases, schema, tables, views, stored procedures, users, groups. Those things you can use in the namespace. And then in workgroup, basically you configure compute capacity. Now keep this in mind and don't confuse that you are configuring compute capacity. You're not going to manage that. So you tell serverless that this is the compute capacity I need, but basically you don't manage it. That is managed by AWS and provided to you. So two things: namespace, which is primarily used to manage your data, and your work group, which is used to configure your compute capacity. Now these two have one-to-one mapping. That means a namespace can have only one work group and a work group can have only one namespace. So they're like ideal pair to each other. And if you look at how does the endpoint look like, this is how the endpoint is going to look like. So basically it's similar to a Redshift cluster endpoint. Two differences you will see here is that in place of cluster name, you have got a work group name. And then in the namespace, you can see here, it doesn't have Redshift, but it has got a Redshift Serverless. So these are the two changes you see in the endpoints. Otherwise, your endpoints is similar to how does a provisioned Amazon Redshift non-serverless versions look like. So keep these two components in your mind, that you configure namespace and workgroup to configure a data warehouse with Amazon Redshift Serverless, and workgroup is where you configure your compute capacity. So how does compute capacity for workgroup going to look like? So how do I configure my workgroup compute capacity, or in reverse, your data warehouse compute capacity? Basically, you configure your capacity using a unit called RPU, which is Redshift Processing Unit. Now you might ask that, okay, tell me that this RPU, one RPU means how many vCPUs and how many gigabytes of memory? Answer is, I don't know, because there is no documentation which talks about what does this RPU, what does one RPU mean in terms of real vCPU or memory capacity. But you can configure your capacity only in terms of RPUs. And when you're trying to configure the capacity, you configure a parameter called base capacity. And in this base capacity, you can provide your RPUs. And basically, what exactly it means is that when you configure a base capacity, like you can see here in the screen, it has configured 128 as a base capacity. What it means is that when you run a query, your query is going to use a minimum 128 RPUs. So minimum base capacity RPUs the query is going to use to run it. Now you again might be thinking that, okay, so if I am configuring my base capacity, how much should I choose my base capacity? Should I choose 32, 56, 48, 128, 512? How much base capacity I should choose? Because Higher you go, the bigger number you go, your query performance will increase. But then you will pay a higher price for your query as well. So how do I choose a base capacity? And answer is you need to do some test and experiments with your query, because there is no benchmark available, and it is not possible to provide benchmark because each query is different. Performance of a query depends on the kind of query, the kind of joins, the kind of aggregation, the kind of table design. It all depends on that. So basically you cannot provide such a generalistic benchmark. So there is no benchmark available, but what you can do is that when you're using Redshift Serverless, you know your query which you want to run your query on various base capacities of RPUs and see that what minimum RPU looks best to you in terms of performance of your query. And if that RPU is good enough, simply select that RPU, that minimum RPU. Okay, so again, there is no formula for base capacity, but yeah, you have to run your experiments with your queries to see what is the minimum RPU which fits your needs. And again, guys, this is the beauty of using serverless, that if you decide with certain base capacity and after say 2 weeks time or even 1 day time, you realize, oh, this base capacity is not good enough, you can always go and increase the base capacity to a higher number. It takes just couple of minutes or seconds to basically change your base capacity from one RPU to another RPU. So changing the RPU is pretty dynamic thing. So you can do some benchmark study for your queries to decide your RPU, but don't think it is a fixed number which cannot change. It can always go up and down whenever you want based on your query requirements. Now, when you are trying to change your RPUs, you can change anywhere between 32 to 512, and change happens in the unit of 8 RPUs only. So suppose you decided that, okay, my base capacity is 32 RPU to start with, the minimum base capacity or minimum RPUs allowed. And tomorrow you want to increase, so you can increase to 40, 48, 56, like that, up to 512. So you can change only in the unit of 8. And again, the higher RPU you choose for a base capacity, the better performance you get, but more cost you pay for your query, the more price you pay for your query execution. So it is always advisable to do some kind of benchmark study of RPUs with your queries and then decide what is the best minimum fit for me. So talking about the cost of the query, how does the cost of the query is how is cost of the query calculated? So basically, cost of the query is calculated using RPU hours. So you see how many RPU hours the query run. And then, for instance, if you take the example of Ireland, in case of Ireland, one RPU hour will cost you $0.387. So you need to say that how many RPU hours your query run, and based on that you can decide you can simply multiply with this per hour cost, and then you can get to know the cost of the query. Now let's take an example to understand it. Suppose that you configured a data warehouse with Redshift Serverless, and you decided that my base capacity is going to be X RPUs only. Now X could be anything, 32, 56, 512, anything, right? Now you run a query which used Y RPUs, and it run for total jet seconds. Now this Y RPU will be either equal to X or more than X. Since you have selected X as your base RPU, your query is minimum going to use X RPU. But your query could be very complex and it might need more than X RPUs, and in that case Redshift will itself determine and assign more RPUs to the query. So keep this in mind, that base capacity means this is the minimum capability or capacity a query gets to run the query. But if query needs more capacity, Redshift automatically provides to it. So Y in this case will be either equal to X or more than X. So, so suppose this query run and it used y RPU greater than or equal to x, and this query then run for z second. In z second, it gave me back a result. So how does the RPU hour going to look like? So the RPU hour will be y into z divided by 3600. So basically number of RPU for how many seconds divided by 3600. Now I'm dividing by 3600 because I'm trying to convert seconds into hour. And that's why I divided by 60 and 62 times. So your RPU hour calculation is pretty simple. You simply see how many RPUs my query used and how long the query run, multiply both, and then divide by 3600 if you are measuring your time of execution in seconds. So what is the cost of the query? Pretty straightforward. It is RPU hours into per hour charge. So in this case, it is y into z divided by 3600 into 0.387 USD in case of if the region is Ireland. So that's how you calculate cost of your query. Now, when you are using a cluster, the beautiful part is that if you're using, like, if you think about like using a DC2 or DS2 or RA3 cluster, in those clusters you need, if you want to save cost, you need to pause your cluster. You need to you to delete it or pause your cluster. Well, don't delete it. You don't delete the production cluster. So you pause your cluster if you're not using it, and that's how you save the cost. But not in case of serverless. In case of serverless, if you're not running any query, there is no cost. I mean, simply you pay nothing. I mean, your cluster is idle over there, so you pay nothing. So that's the good part. Now, when I say query here, keep this in mind, and this is very important, and it's different from how your RA3 or DC2 or DS2 cluster works, is that when you say query, query means both types of query. The query which is accessing data from the local database, or the query which is accessing data from external data, external schemas like S3 table, S3 data which you have configured as an external schema or table in the database. If you're querying data from that, even that query is considered as a Redshift query here. So so both internal queries and like querying internal data versus query of external data, both are considered as a query. But if you are not running any query, there is no cost for it. Now when you are using a warehouse solution, basically there are multiple users who are doing their queries, their analysis on the data. So there will always be a scenario where you are running more than one query. And each query will use their own RPUs. Each query will run for their own time. Like you can see here, Y1, Z1, Y2, Z2. Each will run for their own time. And this query could be sequential queries, could be parallel queries running on the cluster. No, it could be anything, because like you've got like, I don't know, 50, hundreds of users. Each one is simply using the cluster for their own purpose, running their query. So these query, there could be like 100 of queries running in parallel. So for each of these query, it looks into how many RPUs those queries are taking and how long those queries run. And based on that, actually it simply calculates the total RPU hours, which is basically, you can see here that number of RPUs into time run divided by 3600 if you are measuring the tenure in 10 seconds. And then total cost is total number of RPUs into the price per RPU. Like in this case of example of the Ireland, it is 0.387 USD. So that's how the cost of the cluster or the cost of the data warehouse going to look like to you. You have to, it will be the cost of running all the queries in your data warehouse, whether they're running sequential or parallel. Each of the query is incurring their own cost, and when you add them up, it is the cost of running the data warehouse on Redshift Serverless. Now you might wonder that, okay, this is okay, but this is scary as well, because how do I, like in no time I can, because if I like hundreds of users and each user is independent to do what query they want to run, in no time I can overshoot my budget, because it's individual queries which are contributing to the cost. So how do I manage my cost in such scenario? And for that, there are a couple of features in Redshift, which are Redshift Serverless, which are available. So one is that you can manage the cost using usage limit. So basically what you can do is that you can configure your RPU hour usage. So you can say that, okay, my users, all my users, okay, all 50 and 100 users I'm talking about here, all my users can use only daily 100 RPU hours, not more than that. Weekly should not be more than 600 RPU hours, and monthly it should not be more than, say, 15,000 RPU hours. So you can decide some limit for your RPU hours, and that way you know that your warehouse will not be used beyond those RPU hours, and there's no like unlimited bucket for users to simply go and run the RPU hours. Okay, so you can limit the RPU hours at the frequency of daily, weekly, and monthly. And then if your RPU hour is hit, suppose you set a daily RPU hour of 100, and suppose your users run so much query that you hit the limit of the 100, then you can take one of the three actions. So you can either alert, you can send an SNS notification to someone saying, hey, you have reached your RPU hour. In that case, you might want to take some action like increase the limit or do something about it. Or you simply want to simply log it in a system table. Simply, hey, I'm simply going to log it into my system table that, hey, I have hit my limit. So I can use that for my reporting purpose to know that how many times I've hit my usage limit. And third one could be is that you simply turn off user query. You say, hey, my users are not allowed to run any query anymore. And in this case also you can configure to set a notification. So basically three course of action you can take if you hit your usage limit for RPU hours. And if you look at the screen, this is how it's going to look like. For instance, you can see here that I have configured frequency daily 100, and I'm saying log into system table, weekly 650 alert, and I can provide an SNS topic for the alert. And the third one is monthly usage limit, again 20,000 for instance, and turn off the your query. And in this case also I can send an alert that, hey, the person has hit the limit. So up to you, you can configure such limits and alerts for your usage, and that way you can increase, like you can control, you can manage your budget for running the query on Redshift Serverless. Now, there's another way you can also manage your cost, which is basically, I will not say is, yeah, I mean, it can be used, but I mean, like you can, in some cases it cannot. So, and that limit is called your query limit, and you can configure various types of query limit. One very popular query limit is called query execution time, that how long you want to run your query, and why I'm like query to run, and after that I'm like it should not run anymore. And this is useful and not useful both, because in some cases, like if you've got a very big data and if you need to run a query, you need to run a query. You cannot simply limit it by how many seconds you want it to be allowed. But at the same time, you also don't want to be punished for a badly designed query which is running a more than usual time to run it. So it is always a good idea to set this query limit, but I see it more as a safety net for avoiding or safety net for avoiding cost due to a badly designed query. I don't want to be in a situation where a badly designed query taking more than usual time to run and it's incurring me cost. But I will not use it as a way to manage my like query cost, because like I said that if a query needs time to run and it's a good query, nicely designed query, but data is so big, calculation is so complex that it needs that time to run, then it needs that time to run. So from that, you should think this limit more from to control cost due to badly designed query. But yeah, good to know that you can actually set up certain query limits. This is not the only query limit. You can set it your CPU limit and I think memory limit. There are many other limits available which you can set up at the query level to optimize your query execution cost. Okay. So I talked so much about capacity, how you can configure it, how you can configure the base capacity, how to manage cost of it. What about the storage? And because, I mean, if you're running a data warehouse, basically you need compute and storage both. So what about the storage cost? Storage is pretty straightforward, and because you don't configure storage for your cluster. I'll show you a demo where I'm going to launch a cluster for you. You don't provide any storage because storage is completely flexible and managed by Redshift Serverless. Storage will automatically increase and shrink for you as your data grows or shrink, and you don't need to do anything. So basically in Redshift Serverless, you don't configure your storage at all. And you are charged for Redshift managed storage charges. And basically this Redshift managed storage, this concept came with RA3 cluster, because if you remember in DS2 cluster or DC2 clusters, I mean like DC or DS class clusters, basically your compute and storage was bundled together. But then AWS came with RA3 clusters where your compute and storage was segregated. However, there you need to select your storage capacity, but your storage capacity was completely decoupled from your compute capacity. And that storage was called Redshift Managed Storage. So Redshift Serverless also used Redshift Managed Storage, RMS. And but in this case, you don't need to provide any storage configuration. It can simply shrink or increase based on your need. And for instance, RMS cost is $0.024 per gigabytes. Okay. Now, other than storage, you might also want to take various kinds of snapshots of your cluster, like for your backup purpose, for your retention purpose at a later point of time. And for that, standard backup billing works, same as your non-serverless Redshift cluster billing. So there is no change in that. It works same like that. But keep this in mind that as long as data storage is concerned, you don't need to configure it, and you're charged based on Redshift managed storage, which is 0.024 per GB. Okay, so how do I connect to Redshift Serverless? There is no change in that. Basically, you can use JDBC, ODBC driver, just like you have been using earlier. You can use Redshift Data API. You can also use VPC endpoints. If you are running a Redshift inside a VPC and you want to keep the connection private, you might want to use VPC endpoints. So basically, your connection to Redshift Serverless does not change at all. And I have showed you example of endpoint earlier as well. The same way you can use endpoint here as well. Only difference is that in place of cluster name, now you have got a workgroup name, and then in the fully qualified name, you have Redshift Serverless, not only Redshifts. Okay. So how do I migrate from existing cluster? If I'm running some cluster on DC class or DS class or RA3, how do I migrate from there to serverless? Well, it's a two-step and simple process. And like any other migration within Redshift class. So basically in step one, you simply can go to a provision cluster. You can take a snapshot of that cluster. And then from that snapshot, you can launch a serverless namespace. Very simple. So all you need to do is take a snapshot and then simply from that snapshot launch a data warehouse using serverless namespace. Two-step process, similar to how you will migrate Redshift cluster from one to another, right? Now, one another thing. So you know that when I'm using Amazon Redshift, actually you can assign IAM role to Amazon Redshift, and that IAM role can then give Redshift cluster access to other AWS services. So for instance, if you want to access data from S3 bucket, or if you want to talk to Glue catalog, or if you want to talk to any other AWS service, right, from Redshift cluster, like if you're using like machine learning, for instance, within Redshift cluster, you need to access SageMaker, AutoML in that case. So for all those cases, you need to assign IAM role to Redshift Serverless in Redshift cluster, and it is not different for Redshift Serverless as well. In Redshift Serverless also you can provide IAM role. Only difference is that you need to provide trust for one additional service, and that trust is called Redshift Serverless AmazonAWS.com. So similar to Amazon Redshift IAM role, only different is that put additional trust to Redshift Serverless as well. That's the one change you have to keep in mind. Now, I'm going to summarize you some of the key features of Amazon Redshift Serverless, and it will give you a feeling that it is similar to any of DC or DS or RA3 class cluster, and that's the message I want to convey. So these are the summary of the key features which Redshift Serverless provides: snapshotting, UDFs, procedures, using materialized view, special functions or queries, federated query to other data sources, using data sharing, running machine learning, creating machine learning like classification models or regression models right from the Redshift cluster, extending your query to data lakes. No, all those features are available in Amazon Redshift Serverless as well. Okay, so time for the demo. So what I'm going to do is that I'm going to create a namespace and a workgroup. Then I will configure base capacity. I will configure usage limit. Then I will simply try to connect to the cluster, and then I will try to create some table, run data just to show how it works. So nothing very special in a demo, but I want to give you an idea about how to launch a cluster and configure at least your base capacity and usage limit. So let's get started. So here we are in the AWS console. In Redshift, if I go to Redshift console, serverless dashboard, you can see I have already created a namespace with a work group, but I'm going to create another one. It takes some time, so I simply launched it so that I can use this one if need comes. So let's create a work group here. So I simply click on the work group, and remember the work group is where you provide the capacity of your capacity of your Redshift based warehouse. So I call it, say, demo work group. Okay, let's give it a nice name, group. Then I can provide which VPC I want to run, which subnets and VPC group. I can simply provide that thing, and I can provide my base capacity. Let's take a base capacity as 40, for instance. Okay, and next. So I can always change the base capacity later, but I provided some capacity to start with. Now I need to create a namespace, because namespace is where I create my databases, tables, and so on. So let's call it demo namespace. Then I can provide my credential information. So let's give some password here. And then in permissions, I can provide IAM role. I already have an IAM role, which I've created one default IAM role already, which is already configured over here. And if I can show you this IAM role, this is how IAM role was configured. Most important thing here is in the trust relationship. You can see here that other than Redshift, I also have got serverless Redshift. This is very important if you want to use it with serverless. And then I can configure my encryption logging, which I'm keeping by default. I simply say next, don't save. And then here I go. I've got my work group configured, my namespace with the base capacity, my namespace configured with login name, password, and other configuration. I simply create it. Now it is going to start creation of my cluster. I don't need to wait for it, to be honest. And to be honest, I was okay to create it, because if I don't use this cluster, I'm not going to pay for it, right? So what I'm going to do is that I'm going to click on this namespace and work group, which is already created. So if I click on this Dojo namespace, for instance, Here, this is my Dojo namespace where I have got this work group configured. Here you can see your backup information, security information and configuration, data sharing configuration, and so on and so forth. I'm not going there. It's similar to how you use Redshift, okay, non-serverless version. Now, if you click on the work group, basically here I can you can see here that this is where I configure my compute capacity. So let me reduce that. You can see my endpoint configuration here. It's similar to the non-serverless Redshift cluster, but yeah, only difference is that you have got work group in place of cluster name. You can see your network configuration, your VPC endpoint configuration here. Now, if I go to limits, this is where I can configure my limit. So here I can configure my query limit, usage limit, and my base capacity limit, base capacity. So if I go over here and say, by the way, this one I configured with 32 base capacity only. So if I go here and say, hey, I want to change it, I can simply go and change it. And you can see here, it can increase on only in the value of 8. So if I do it, it will take a couple of seconds or minute to change, so I'm not going to do it. But I showed you how and where you can configure or change your RPU capacity at any point of time. Now here I can set up my usage limits. If I go to my manage usage limit, I can stop. I can do a cross-region data sharing limit as well. I'm not going to that today. But let's talk about your RPU limits. If I say add limit over here, I can set up my daily limit, weekly limit, monthly limit. So I can simply say, okay, my daily limit is 50, which is nothing, but yeah, I log it to system table, and then my my weekly limit is say 250, and then this I can send alert. If I do alert, I need to configure a topic here, which I don't have right now, but I wanted to show you configuration. Then if I go for like a monthly, you can see here I can go turn off my user query, and in this case also you can configure a SNS topic for sending a notification that your user queries has been turned off due to limit hit. So this is how and where you can configure your usage limit. If I go back to data, okay, here we go, limits again. And then going to the third one is query limits. If I go to manage my query limits, you can see here it has my query execution time, but you can add more limits here. For instance, query CPU time, block reads, CPU usage, your return row count, memory to disk, query CPU, yeah, those kind of things. You can configure more limits here about how much capacity you want to allow your query to use. So these are a few things you can do to control your limits. Now let's see if I want to query data, how does it look? So if I simply, I'm on this work group over here, I can simply say I want to query data, and it should open a new console using query editor for Redshift Serverless. And here we go, we have got query editor over here. And you can see here that my demo work group is still coming along while my Dojo work group is already in place. So I can simply expand it. I have got my dev database over here, and I've got my public schema, then my tables. And basically I have no tables right now. So what I'm going to do is that I'm going to first create a table. And I'm doing it just to show you that it is same as running any Redshift cluster, like the non-serverless one. Okay, so I created my table, so same as earlier. And then I'm going to simply insert my data into it. So probably I just used this cluster for the first time. So in the first time, the cluster might be starting, so it's taking some time to create. But I think once I run one query, the second query will be faster for me because my cluster was already be in place. So yeah, here we go. My table is created. Now, if I want to insert my data into it, I simply run another query. I'm simply running my data. Inserting my data. It should take very fast because my cluster was already in place. And then I simply can go and run another query showing how you can fetch data, which again takes no time. So it's similar to how it's very similar to how you run your query in your non-serverless Redshift cluster, whether it's a DC class, DS class, or RA3 class. So that's what I wanted to show you today, that how you can use serverless, and most important, how to configure capacity, how to think about planning capacity, how to calculate cost of the query, how to use the limit to control the cost for running your cluster on serverless. So these are the few things or important messages I want to communicate today. And that is all for today, guys. And hope you like the video. If you like the video, please click on the like button. Please subscribe to my channel. I promise to come back again in a week's time with another such video. In the meantime, please stay safe and have a nice day. Bye-bye.